Hey guys, this is Coach Lowe, and we are going to start lesson 6 today in our geometry. Yay for us. All right, so section 6, two-dimensional figures. Add the following to your definition section. A polygon is a closed figure. That means there are no gaps in the sides. They're all closed, all connected. Closed figure formed by a finite number of coplanar segments called sides. Finite number means there's a specific number of segments, not infinitely many. Vertex, corner point where the two sides meet. We've talked about vertex with angles. So if I draw a five-sided figure here, I have vertices. That's the plural for vertex. I have vertices here where those sides, two sides are meeting. This would be a polygon because it's a closed figure. This would not be a polygon because it is not a closed figure. So you can see there's a big gap there, not a polygon. Not. Okay, equilateral polygon, that's where all the sides are the same measure, all the sides are congruent. Equal angular polygon is where all of the angles are congruent. All right, so pause the video and write those down. If you want to draw some pictures, you can. If we have a polygon that's equilateral and equal angular, then we have a regular polygon. All the angles are equal, all the sides are equal in measure, then it's called a regular polygon. All right, example number 1. Name each polygon by its number of sides, then classify it as convex or concave, and then also classify it as regular or irregular. So remember, regular, equilateral, equal angular. So same sides are the same measure. We're looking at sides and angles for a regular polygon. All right, convex or concave. If it's convex, then, if it's convex, then as I draw, like extend the sides, they will not go to the middle of the figure. That means this one is convex. And then look at the markings. We see I have equal angles. That's what those mean. So the angles are equal in measure. And then I also have markings on the side showing those are all equal. So this is a regular polygon. And then how many sides does it have? 1, 2, 3, 4, 5, 6. So 6 sides, which makes it a hexagon. Good job. I know you're saying that with me. All right, so look at number 2, and you can try the rest of these out. Pause the video and try them, and then start it back up, and I'll go through them. All right, now that you've started the video back up, number 2, 4 sides, quadrilateral. And all sides are the same length, which makes it regular. If you extended the sides out like you were supposed to, it does not go through the figure, so it is also convex. Right? As we look at number 3, watch what happens as I extend this side. Bam, right through the figure. It is concave. Also, you can think about concave, it's bowing in, and you can see that the top of it looks like somebody sat on it, just flattened it out. And then the markings, I only have 3 of the 5 sides. By the way, 5 sides, pentagon. I only have 3 of the 5 sides that are equal, so it is not regular, it is actually irregular. Continuing on, number 4, we have a triangle. Everybody should have gotten that one. Woot woot. A triangle, it's irregular, not all the sides are the same length. And then is it convex or concave? Extend those sides out, none of them go through, so it's convex. All right, 1, 2, 3, 4, 5 sides makes this a pentagon. So sides, remember, we're looking from vertex to vertex. That's a side. This goes right through the figure, so it is concave and it is irregular. Good job, guys. All right. 1, 2, 3, 4, 5, 6, 7, 8. Octagon. Irregular. And concave. Nice work. All right, on to our last example, area and perimeter. Now this is kind of throwback 6th, 7th grade probably for you guys, but we always need this reminder. We will use this throughout the next 3 years of high school. So let's check this out on the triangle. The perimeter, remember, we're walking around the outside. So add up all the sides. And for the circle, we're talking circumference. So when I talk about the circle, remember the circumference is 2 pi times the radius, or you can use pi multiplied by the diameter. I see we have radius on number 2, so we can just use 2 pi times the radius. All right, so let's do perimeter of this triangle. Adding up all the sides, P standing for perimeter, 2.5 centimeters plus 3 centimeters plus 3.5 centimeters. We don't care about the height right now. We'll come back to that in a minute. All right, so adding all those up, remember to line up your decimal place, 2.5 and 3 and 3.5. So that's 6, 7, 8, 9. So 9 centimeters. That's the perimeter. So walking along this outside of the triangle, 9 centimeters. All right, now let's find the area of a triangle. When we talk about area of a triangle, I want you to think about a rectangle. If we kind of check out a rectangle, we want half of that. Remember, a rectangle is base times height or length times width. We want half of that with a triangle. So it's base times the height or length times width, and then take half of it, or multiply it by 1/2, divide by 2, same thing. All right, so my base, you know, because we're all about the base. Base is here. Height is there. You knew that was going to happen, didn't you? Base there, height there. So I have 1/2 base times height. All right, when I multiply that out, I should get 3.5, and this is centimeters squared. Okay, so how can we do that quickly? If I put 1/2 and 2 together, because we're multiplying, we could do it in any order. So if I swap places with those, half of 2 is 1. Those are reciprocals of each other. So 3.5 centimeters squared is my final answer on that. So I have perimeter, and I have area of that triangle. All right, so let's move on to the circle. Circumference. 2 pi times the radius. They gave me the radius. Radius goes from center of the circle to the edge of the circle. So circumference is 2 pi times 4, or 8 pi. If you would like to use a calculator to give me an approximation, you surely can. It says round to the nearest tenth. So you should be able to actually estimate 8 times 3, 24, because pi is about 3.14. So you should be able to give me a pretty close estimate to what your answer should be before you put it in the calculator. It actually ends up being about 25 and 12 hundredths, and it said round to the nearest tenth, so I'm just going to go ahead and do 25.1, and that was in feet. All right, so that's the circumference. Circumference, remember, distance around the circle. Circumference, walking around the circle. All right, now let's talk about area. Area is going to allow me to fill in the circle. All right, so area is pi times the radius squared. All right, pi times the radius squared. I'm going to switch colors. Area is pi. Look at that, blue and gold. It's just beautiful together, isn't it? All right, area is pi times the radius squared. So I have pi times 4 squared. 4 squared is 16. We have to square the number first. Remember, order of operations. We'll square it first, then multiply it by pi. So 16 pi for my final answer, and that's in feet squared. 16 multiplied by 3.14 is 50.24, so I'll just put 50 and 2/10, and that would be square feet. Remember, we're covering the inside of that circle. All right, we're at 8 minutes, so of course I just need to do one more problem. I know you guys will be super excited about this. So think about this problem. A little challenge here for you. We have a rectangle, and the area of the rectangle, let me just go ahead and draw you a little picture here. The area of the rectangle is 360 square yards. Come on now. There we go. 360 square yards. And I will also tell you that the length of it is 10 times as long. So it's 10 times as long as it is wide. We don't know the width, but I know the length is 10 times as long as it is wide. Could you please find the length and the width, the dimensions for the length and the width for me? Pause the video if you need to, and then you can come back. All right, so the setup on this, we know area of a rectangle is the length times the width. So my length is 10x My width is x. I also know the area is 360. We can solve this equation. First, let's simplify the right side. When we multiply like bases, x and x together, we add our exponents. There are ones there. So x times x is 10x squared, or is x squared. So we get 10x squared. Then I will solve for x. So 360 equals 10x squared. I'll divide by 10 first on both sides. Last thing I'll do is take the square root. Dividing by 10, 360 divided by 10 is 36. And then that's equal to x squared. 10 divided by 10 is 1. Take the square root so that we can get x by itself. X is equal to really plus or minus 6, because 6 squared is 36 and negative 6 squared is 36. But we're talking about length here, so we will toss the negative. So x equals 6. All right, so that would be the width. X equals 6 yards. So what about the length? The length is 60 yards. All right, good job, guys. And just for Max, this is Coach Lowe signing out.